Alright, so today we are doing range. Range is going to be very similar to domain, but we're using the y values. So range are y values. And for the range, you are going to go down to up. You have to go down first. So think, how far down am I going first? Down to up. All right, on this absolute value function, how far down am I going? Infinity, yeah, negative infinity. And how far up am I going? 3. So 3, very good. Your graph goes all the way up and it stops right here at this corner 3. Is 3 a point or an asymptote?
It's a point.
It's a point. So do I have a bracket or a parentheses?
A bracket.
Very good, a bracket. So down to forever, so negative infinity. You go up to 3, that's the highest point of your graph, and it's at 3. Inequality notation, same thing, negative infinity, less than y, less than or equal to 3. Why do I have the equal to?
Because it's a point.
Because it's a point. Okay, and then set builder. Remember set builder, we don't want the infinity sign anymore. You're just going to put the other part of your inequality, y is less than or equal to 3. Another way of thinking about it is you can look at your graph. Your graph stops at 3 and it's going less than. Right? You're using the y values less than 3. So you stop at 3 and you're using the values less than 3. Okay. Quadratic is next. So how far down is my quadratic going? Negative 2, bracket or parentheses?
Bracket.
Very good. How far up?
Infinity.
Very good. All right, for inequality, negative 2. Is it less than or less than or equal to? Very good. Less than or equal to y less than infinity. Alrighty, and then set builder. What's going to go inside set builder? Yeah, greater than or equal to negative 2. Very good. All right. Cubic is next. On the cubic one, how far down am I going? Negative infinity. How far up?
Positive.
Positive infinity. So for the inequalities, I'm going negative infinity, less than y, less than infinity. Okay, and then for set builder, do y'all remember what I got to put in there? Yes, the all reals numbers are y with the little in symbol is included in, and then the all real numbers symbol, the r. All right, so you're going to use this notation anytime you go from negative infinity to positive infinity. You're using all the numbers.
That's the worst thing to hear is, what if somebody was like breaking your heart or
All right, this next one is an even radical, like a square root or a fourth root or something like that. So this is a point. It stops at. Yes, so how far down am I going? 0. Be careful you don't put negative 4, all right? You are going down to this point. The y value is 0. All right, so range is y. So we're going down all the way to 0. And we are going up to infinity. So 0 less than or equal to y, less than or equal to infinity.
Isn't it just less than infinity?
Oh, yeah, my bad. That's not supposed to be there.
and G.
Oh, you do. That's okay. I have mine.
We have the same one.
Nerd. She have an upgraded version. Oh my god.
It's weaker.
Nerd.
Where did you buy that at?
I can't even tell it was there.
Nope.
Until you actually look at it on the
Okay,
paper.
but some white else you can tell.
Yep. All right, and then in Step Builder, y and very good. Y is greater than or equal to 0.
Why would you? Never mind. Because I'll tell you some questions. Girl.
All right, going down to these bottom ones.
I did pizza yesterday.
All right, so on this odd radical, like a cube root or a fifth root or something, how far down am I going? Negative infinity. It is going down slightly forever. Yes.
Why is the first one, the sign is going towards 3, but then for the other
You
one
gotta
is
follow
going
the
to
equation.
Y?
Wait, say that one more time.
Like, the less than or equal to sign is going to 3, and then all the other ones are going to Y.
Oh, okay, because you have to see how well, okay, in your graph, you're using the values less than 3, right? So that should be a less than sign. But this one, we're using the values greater than -2.
Oh, okay.
So that's a greater than
So that
sign.
one's going down.
Yeah.
Okay.
Yeah, your function's going down on that one, so it's less than. All right, and then on this one, how far up am I going? Infinity, very good. All right, for the inequality, negative infinity, less than y, less than infinity. Okay, and Step Builder is going to be what?
Y is R. All real numbers.
Yeah. Y is in all the real numbers. Good. All right. Okay, so just like domain for the rational function, since you have 2 parts of your graph, you are also going to have 2 parts for your intervals and 2 inequalities. Always start down. Whatever function is going down, that's where you're going to start from. So, how far down is it going? Negative infinity. And it's going to go up all the way to what number? 3. Is that a bracket or a parentheses?
No, it's not. It's a
Parentheses because it's an asymptote. So remember, the rationals, exponentials, and logs, those are the 3 that have asymptotes. So we go down to negative infinity, we're going up to 3, and then this one goes down to what? To 3 and up to positive infinity. Alright, so just go from down to up. Don't try to skip around. And if you look, there's kind of a pattern happening, right?
Oh, it looks like the.
You see like it's flipped around?
Yeah.
Okay, it's going to be like that. These numbers are going to be the same because that's your asymptote. Just be careful with your infinities. This one's negative, this one's positive. This down is negative, positive's up. But you're going to have that pattern. And then same thing for the inequalities. You're going to have 2 inequalities, 1 for each interval. So you're going down to negative infinity, less than y is less than, up to 3. No line because it's an asymptote. Right, no or equal to line. And then the other one goes down to 3, less than y is less than, and then up to infinity. Do y'all remember what Step Builder looks like for this one?
Y equal with slash not through. Y does not equal 3.
Yeah. This is the only one that is going to have the equal to with the slash. Alright, the only one that's going to have the equal to with the slash, because you have to have these 2 parts to cover all of your graph. Right? This part's covering the bottom half, this part's covering the top half. The only number you're not using is the asymptote 3. Alright, so this is covering the bottom half, that's covering the top half. The only number we're not using is the y value 3. Okay? Almost done. This one I have my asymptote right. Do what?
No, this side is just
So I have my asymptote right here in my exponential function. That's the exponential one. Alright, so for the range, how far down am I going? -3, yep. And how far up? Infinity, very good. For the inequality, -3 less than y less than infinity. Okay, and then for set builder, am I going bigger than 3 or less than 3? Or, I'm sorry, bigger than -3 or less than -3? Bigger, so that's why it's a greater than sign. Also, it eats the y here. Oh my gosh. No bar though, no bar. Oh. I'm making a mess with my whiteout.
Oh,
It's okay.
it's like art.
Yeah, that's, oh yeah.
I took art.
And then -3. Alright, last one. Alright, this one we have an asymptote right here in my log function. Goes like that. Yes, very good. So we're going down to -infinity, up to infinity. There is no asymptote that is stopping your graph from going up forever. So even though it looks like it's going to go straight out, it is going to go up forever because there's no asymptote there that's stopping it. Right? Your asymptote is the vertical one. And so then inequality and set builder are just like the other ones. The all real numbers. Alright, so the last part here says the domain of, and then you have 6 blanks, are all real numbers. So, there are 6 functions where the domain is going to be all real numbers no matter what, every time, no matter what your function looks like. If it is a, whatever it is, then it's going to be in all real numbers. So, 16.
You just wanted to be.
Kiadra, tell me one of them. Yes, you do. It's a linear absolute value. The numbers are around the room.
What you just said.
And look to the front. Which one of these functions has all real numbers for the domain? The infinities. There's 6 of them.
I tried to help.
Just throw one out there. It's probably going to be right.
I can't think right now.
All right, Faith, help her.
Absolute value.
Absolute value, good. The absolute value will always go left and right. So if you have a function that looks like a V, the domain is going to be the all real numbers.
Right.
Okay, 19. Caitlin. What's another one? Quadratic, very good. So if you have a function that looks like a U, your domain will always be left and right. 17.
Why are you in this area?
I don't know, I keep pulling gold ones. Briseda. Which one will go left and right forever? Cubic, very good. Cubic. 3.
That is cheating.
Tell me what your name starts with. Ariana? Ariana. Tell me what was it again, Ariana? Odd radical, very good. Odd radical.
Please keep it going in order.
21. Diana. 2 more. They're gonna be on that side of the room. Got 50-50 shot. Linear, yes, linear. It's actually not on your paper, but it will go forever left and forever right. And 7. Daniela, is that you? What's the last one? We already did those. Oh, wait, no. No, I need one more over here. I'm sorry, yep. Say it again. No, for domain. It's not the log one. The domain's going to stop right here.
Is it because it has an asymptote?
Uh-huh. So what's the other one that has an asymptote? That'll go forever left and forever right. Say again. Exponential, good. Exponential.
Exponential? I thought it was
They're out of order.
So this one is exponential right here. This one is exponential. Because you're going forever left and forever right, that one, the domain, will always be the all real numbers. The reason why rational is not going to be all real numbers is because you have a number that x will never be. X will never be the asymptote.
Oh, that's irrational.
Yeah.
Why doesn't it have the other
Which one? This one?
That's right.
This is this one? Because this is the range. If you look on the front of it, and it should have all real numbers on the domain part.
I probably should put it on there so whoever might watch it.
That's true. I probably should. I'm gonna do that. All right, so let's do the range now. So the range is on the back. So all the ones that have the all real numbers on the back with the range. 1, Evelyn. Cubic, very good. Cubic. 18. We don't have an 18. Who wants to do it from that table? Josh, you want to do it?
That's being voluntold. That's not.
Josh, you can help me. Which range is all real numbers? Which function has a range of all real numbers? Either one. There's one on either side.
That log.
The log, very good. Yeah, the log. Okay, and 6. Which one has got it? Odd radical, uh-huh. All right, last person. 14. Faith.
Isn't it like even radical?
No, even radical's not. It's actually not on your paper, but it's up around the room.
Linear.
Yeah, it's linear. Trick question.
I
Linear.
didn't expect to get called.
Linear. Linear will go forever down, forever.